There is no limit to inquisitive mind and perfection of knowledge. The Infinite Science program focuses on the latest scientific achievements, new developments and unique discoveries by Kazakh scientists. Infinite Science is an opportunity to see the future of science.
In 2014, a team of scientists from IBM created a chip that has an architecture that is identical to the human brain. The chip has 4 billion transistors, which, just like the human brain cells, are connected by synapses. The creators of this chip are confident that this invention would contribute to the improvement of the functions of computers in processing complex tasks, ignite the development of computer vision, and will move science closer to the development of artificial intelligence. Hello, my name is Yerkebulanbek Muhanbet. You're watching Infinite Science. In today's episode, Prospective materials, how to get gallium nitride fast. When quality takes over quantity, computational grid from Kazakhstani scientists. Starter cultures for fermented dairy products. 20 years ago, Japanese scientists created a light-emitting diode that can emit blue light. Last year, for their work, they were awarded the Nobel Prize. The invention of the blue light diode was a breakthrough in the field of light technologies. In combination with green and red diodes, it becomes an effective and environmentally friendly source of white light. The scientists used gallium nitride in their research, a special compound of gallium and nitride. Currently, specialists are continuing their work on advancing the technology used in obtaining this compound and expanding its spheres of application. Gallium is a light metal that interacts with oxygen and as a result oxidizes. That is why a state of perfect vacuum is required for obtaining pure gallium nitride. It is very difficult to create such conditions. However, researchers at the Nazarbayev University have developed a creative solution. They get this compound using a magnetron of the last generation. Here, everything is programmed into the computer, which is used to control the whole process. The only thing that is required from a person is to put there whatever it is that they want to spray, put a lining surface, and that's pretty much it. Everything else can be programmed into the computer, which does everything automatically. The magnetron in itself is an electronic lamp that is capable of generating high-frequency electromagnetic waves. Kazakhstani scientists used it for the creation of the state of vacuum to the -9th and -10th degrees. This method turned out to be fast and less costly. With the use of the magnetron, the necessary material, or compound, develops in the form of a film. For this, gallium is put into the machine, which is then diffused. Gallium is diffused in interaction with nitride, which is supplied through a special system. In an hour, the high-quality compound is ready. Gallium nitride has a number of unique properties. One of them is high resistance to ionizing radiation. This is very important in the production of solar batteries for spacecrafts. That is why Kazakhstani scientists are thinking about the prospective use of this technology, specifically in this field. The main problem today with the production of solar batteries is the cost of these batteries. The magnetron allows us to get these films at a very low cost and of relatively good quality, and what's also important, in a time-efficient manner. Scientists are confident that the technology for obtaining this promising compound with the use of the magnetron will be useful not only in the field of solar energy, but in other spheres of science and technology as well. In 1999, astronomy scientists from the University of California, in their search for extraterrestrial civilizations, employed an innovative approach. In order to decode the signals from space, they attracted participants with simple PCs from all over the world. The most large-scale collective computer project in history united 5 million users from 200 countries. Today, scientists use this approach in the solution of complex problems that require high calculating capacities. It is not a secret that supercomputers solve super problems, but even they can sometimes be incapable of solving some problems. However, this can be done with the use of simple PCs that are united by a single grid system. A grid system is a type of distributed computing, one of the types of distributed computing that allows us to speed up the problem-solving process, whether it is a mathematical problem or economic, without requiring huge computational resources. A similar technology has been used for some time already in large scientific projects. For example, for the modeling and processing of data received from the Large Hadron Collider. Another big project is SETI, the search for extraterrestrial civilizations. Here, the system of distributed computing is represented by the International Platform for Computing using voluntary resources, BOINC. The thing is that radio telescopes intercept a huge amount of space noise which cannot be processed even by 100 supercomputers. That is why small fragments of this noise are studied not only in the scientific centers, but also by people from all over the world from their homes. However, smaller projects require resources of a much smaller scale. Each higher education institution that has facilities engaged in mathematical and computational research should have a grid system if they do not have a computational cluster. Researchers at the Kazakh National Technical University, named after Satpayev, created their own grid system on the basis of the BOINC platform. Here, at the National Scientific Laboratory of Collective Use of Information and Space Technologies, they've united hundreds of computers from a number of universities. At the moment, the grid system is used on more than 600 computers at the Kazakh National Technical University and at the International University of Information Technologies on about 25 computers. There's also cooperation with the Turan University and the Kazakh National Technical University, named after Abay. Today, the Kazakhstani grid system is working on specific applied science projects that require complex calculations. One of them, development of an automated speech recognition system. Once the main problems are resolved, it will be possible to control the computer's functions by voice and in the Kazakh language. The fundamental task of science, in the most simple terms, is to understand the essence of things, and in applied science, to learn to apply this knowledge in the right direction. Thereby, science touches upon all spheres of human activity and life. Even what we eat and drink is partially a result of scientific progress. Traditional Kazakh drinks, hummus and shubat, are a wellspring of necessary microelements and vitamins. In order to make them, a method of selection is traditionally used. The best quality drink is stored for fermentation in the next season. There are a number of risks connected with this method. What's more, it cannot be used in industrial-scale production. In order to solve this problem, Kazakhstani researchers at the science and production enterprise Antigen have developed specialized starter cultures for hummus and shubat. Starters are ordinary fermentation cultures. They are used for fermentation of products, in this case of milk. This is a group of microorganisms that make up a sort of consortium. The use of standardized groups of microorganisms allows for the rational use of milk with minimal loss during the selection process. What's more, these starters make the process of making these beverages safe. Thanks to them, microbiological stability is maintained. With the use of our microorganisms, you will know for sure that they contain fermentation bacteria. Hence, you will know for sure what process will take place in the milk and what kind of product you will get. In the preparation of hummus, Kazakhstani scientists use 11 types of microorganisms. For shubat, 9. Each microorganism gives a specific property to the beverage, in terms of thickness, taste, and color. Thus, by choosing the optimal combinations, Kazakhstani scientists have managed to maintain the rich taste of traditional drinks. We know that microorganisms can show antagonistic activity or engage in a battle for the substrate among themselves. We choose microorganisms in such a way that they would have a good symbiosis. Creation of starters on the basis of local cultures solves one of the main tasks: preservation of microbial flora of Kazakhstan and of its diversity. Their use will also help significantly increase the production of national fermented drinks in the country. There is a saying that history repeats itself. In the field of science, this is somewhat different. In order to invent something new, it has to be a breakthrough. Yet sometimes it is enough to find a new application for an already existing invention. More on this in our next episode. Discover infinite science with us. Until next time.